Dear students, let's finish our course on the topic of linear circuits, a consideration of non-linear circuits, electrical circuits, which we consider on the example of consideration of electrical processes in a transformer with a ferromagnetic core. We have primary circuits, secondary circuits, and they are located on a magnetic core with nonlinear ferromagnetic dependence of its permeability on the level of applied currents here, of applied voltages, and we write down equations which depict connection between applied voltage and current in primary circuit, then in secondary circuit, then as we have common phi0 flux in primary and secondary circuit, we write it down with such designations, and then we try to consider this nonlinear process with the help of phasors, some approximation, of course, and we write down such an equation as phasors. These two equations for U1 and for U1 and for U2, we write it through phasors, and then we introduce such an approach when we reduce number of winding of secondary circuits, when we consider that this number of this winding in the secondary circuits equal to number of windings of the primary circuits. And for this, we should virtually, of course, change current in secondary circuits. It will be equal to I2 over N, where N is W1 over W2. And in such a case, this flux phi0 will remain unchanged, and so we may consider these processes with such an approach, with such approximation, and here resistance and inductance and inductive impedances of the secondary circuits will be recalculated in proportion to n power 2, where n is W1 over W2. It will be greater than 0 because in all transformers number W1 of primary winding is greater than number of V2 of secondary winding. Why? Because we would like to have, for transformers, as a rule, we would like to have bigger current in secondary circuit than it was in primary circuit, and it may be gained by decreasing of the number of winding of secondary circuit relatively number of winding of primary circuit. So we will introduce here this coefficient n W1 over W2, and as we have here we have multiplication of number of winding here, number of winding and current will be proportional of number of winding. Also, we will have this ratio between number of winding of primary circuit and secondary circuit and power 2, because voltage is proportional to power 2 and currents will be reciprocal to in the secondary winding will be reciprocal to this n parameter. So after such a reduction, we can rewrite equation for a transformer with the help of such primary parameters. Primary parameters means that we use this W2 primary equal to W1. So first equation, this equation will remain unchanged. You see, it is U1 equal to R1 I1 plus J omega LS1 I1 plus this UF. It corresponds to voltage drop due to presence of this F0 flux. And second of this equation will be changed. You see, we have here U2 prime equal to R2 I2 prime, yes, and R2 prime I2 prime plus J omega LS2 I2 prime, this signs prime equal to I2 prime. So we change that. And here U2 prime equal to ZL2 prime, ZL prime plus multiplied by I2 prime. And let's rewrite also relationship between induced flux FO and magnetic force I1 plus I1 W1 plus I2 W2, and let's rewrite it by changing this summand. So we can write down, we have such an expression for phi0, where it is, 1 minute, phi0, where it is. Let's write down. Let's write down it. Sorry, we can write down that phi0 equal to I1 maximum W1 plus I2 maximum W2. You see, it's for phasors. For phasor, I have not found it. Not for phasors. 1 minute. Let's find it. So let's write it in such a way. Over that M, it's Rm JXM, it's complex magnetic impedance of a core. XM, it takes into account losses of core because of hysteresis and eddy currents. You see, we have if we introduce some hysteresis in such a case, we have some losses here, and it may such losses may be taken into account. So we take here active losses due to hysteresis and magnetic losses due to hysteresis. So we can write down that in such a way through non-changed secondary parameters, and we can rewrite this equation for the case with primary signs. We write down that it's equal, instead of I maximum W2, we write down I maximum 2 prime multiplied by V2 W2 prime, and we choose this primary parameter with primary signs in such a way that this product equal to this product, because here current number of windings of primary parameter is considered to be bigger, and now current with prime side will be less. So this product will be the same. Then we can as V1 equal to V2 prime, we can write it just as double. So W1 equals to W2 prime, as we considered previously. We can put this W1 before these brackets over Z maximum, Zm, and in brackets it will be I1 maximum plus I2 maximum with prime sign. Or if we consider that this sum of these two parameters equal to I0 maximum, we can rewrite it as I0 maximum I0 maximum W1 over Z maximum. And this current UOM equal to IOM equal to I1M plus I2M with prime sign, it is called magnetization current. Here magnetization current. And in such a case, we can draw equivalent circuit of in such a case. And here we have R1 LS1 as primary circuit, LS1 prime sign, so it should be 2 here. IS2 prime sign, R2 prime sign as secondary circuit, and here we have additional circuit which correspond to presence of this magnetic ferromagnetic core with losses. So we have here B0, it is this susceptibility B0 depends on voltage UF, this voltage UF, here, sorry, bad designation. This voltage UF is connected with presence of hysteresis loops and with active losses due to this hysteresis loop. And conductance G0, it's constant quality of a condition that losses in a core are proportional to UF power 2. So they are proportional to B maximum power 2. See this Y power 2, because we have here product of current and voltage. So we have here voltage drop across this branch, it's UF, yes, and so we can present an equivalent schematic of such a transformer which takes into account voltage drop and active voltage drop and reactive voltage drop across primary circuit, the same parameter across secondary circuits, and presence of this linkage F0 and also active and reactive losses in this core. We can present it in such a way, and we can consider electromagnetic processes in such a case. It's easier. It's of course it's approximation, but it's easier, and it may be considered with the help of phasors. And in your further courses, you will consider in more details processes in such transformers and electric machines, but this material will help you to comprehend better for more detailed consideration of this process. So this course is over, and I hope that if you have any questions, please ask me, and I will try to answer to help you with comprehension of this material. Next week will be a week for you to try to finish your home assignments and send it to me, and maybe I will send you your exam papers for each of you, and please write answers on these questions. Please solve problem which will be included in these papers. Send it to me in clear handwriting with nice photographs of the sent material, and please indicate in the beginning of these papers your name, number of your group, number of your variant, number of your exam paper. If you will not send me your home assignment, and if you will not perform and pass your laboratory works, your exam grade will not be high, but you all the same you will be able to pass this exam if you send me at least answers, proper answers on exam questions, you see. So please try to pass this exam, and I wish you good luck in your future professional career, and I wish you good luck in passing this examination. It's quite possible. Please try to do it. Please send me your answers, and bye-bye for now. It was nice to be with you all this and previous semester. Bye.